Hello guys, once again this is Dr. Possibility from Excel Academy. Guys, I have some good news for you. Excel Academy will be offering second year medicine and surgery courses, second year pharmacy, biochemistry and any health related program. Please make sure that you register with us. We are going to provide quality and best services that you all deserve. Please, we as Excel Academy are encouraging each and every student to register with us before you even open. Thank you. Let's get started. So in today's class, I'm going to explain about water and I'll use multiple choice questions. So as you know, water is just a molecule which is made up of one oxygen atom and two hydrogen atom. These two elements, they do form a covalent bond. But I'm not really interested much in explaining about water, but I'm just simply going to solve some questions. So, which of the following statement is correct? So, the first option is a water molecule is electrically neutral. The second option is saying some water molecules are positive charge while other water molecules are negative charge. So this statement is wrong, and you need to be very careful in dealing with such statement. So here they are saying some water molecules are positive, so they are not referring to the component of the water molecule. Instead, they're talking about a particular water molecule like oxygen, and you have hydrogen there, you have hydrogen there, of which you know that hydrogen is partially positive, hydrogen also is partially positive, and oxygen is partially negative. Then here they're saying that some water molecules, let's say this one is positive and another water molecule is negative. So the statement is totally wrong. Water molecule normally repel one another. No. So we need to understand that because of the partial charges on the water molecules, these water molecules, they normally create what we call cohesion forces. They have a chance of creating cohesion forces because of these charges. So these cohesion forces are as a result of the hydrogen bond which is formed. So you find that this guy is capable of forming a hydrogen bond with that, and this force, a force which is existing, so you have the hydrogen bond there, and the force which is existing is the cohesion force. So you find that water molecules, they just attract each other and not repelling each other. So water molecule have a small positive. No, it's not supposed to be positive. Instead, oxygen has to be negative. Okay, then the distribution of electrical charge on water is such that oxygen end is partially negative, whereas hydrogen end is partially positive. Okay, so the distribution of electrical on water is such that, so hydrogen end is partially negative, which is correct, and then the hydrogen is partially positive. So the answer here is this guy here. Now I go back to a water molecule is not electrically neutral. No. Despite the fact that water is partially positive and partially negative, these charges, they are able to cancel each other. As a result, a water molecule is electrically neutral. So it is electrically neutral. A water molecule is electrically neutral. So we should all make sure that we understand that part. Okay. Let me quickly go down and look at the other questions. So please make sure that you subscribe to our YouTube channel and and register with us. In liquid water, the different molecules are held together by hydrogen forces. So different, we are talking about different water molecules. So if this is a water molecules, oxygen, hydrogen there, oxygen, hydrogen there. So this water molecule is capable of forming hydrogen bond with another water molecule, which is having oxygen there, hydrogen there, another hydrogen there. Okay, and remember that when dealing with water, you need to make sure that you understand that the bond exists between hydrogen and the oxygen. Okay, the hydrogen bond, the Hb. The Hb is normally existing between hydrogen and the oxygen. That's where it's normally exists. Okay, yeah, and this water molecule is capable of forming Hb with other molecules, of which 4 water molecules. Okay, so one water molecule has that ability of forming 4 hydrogen bonds with other water molecules. So when oxygen combines with water to form water, there are 2 lone pairs of unshared electron. There is 1 lone pair. So the answer here is just simply there are 2 lone pair of unshared electrons. So these lone pairs, they also cause the shape of a water molecule. So we find that the shape of a water molecule is somehow bent. It's not straight, it is somehow bent. Okay, so since it is bent, it forms an angle there, like I said in the previous video, which is 104.5 degrees to 109 degrees. All right, so let me quickly go down there. So the next question, which should be my number 4, the bonds that are broken. So the bond which are broken when water evaporates, it's not the covalent bond but the hydrogen bonds. Take note of that. It is the hydrogen bonds which are broken when water is evaporating. It's the hydrogen bond which are broken and not the covalent bond. So the answer is just simply hydrogen bonds. Okay. Let me go next question. So the next question is saying water molecules are held by I love this question. So this question is saying water molecules. So they are talking about different water molecules. So these 2 different water molecules are just simply held by what? Hydrogen bond. Okay, so they are just held by hydrogen bond. Okay, so the answer is just simply that one. Okay, which is very easy to do. Identify the 4 statements. Water adheres to the surface of the container. Yes, it does, because of what? Adhesion forces. Because of adhesion forces, water simply does that. Water conducts electricity. Like really? There we need to put a question mark. Water can dissolve proteins. Yes, because we know that proteins are what? Are polar. We know that proteins are polar. Water stick to grass because of cohesion forces. I'm going to pause a bit that. Water moves along blood vessels because of that. Okay, this one is also correct. Now let's look at water conducts electricity and water sticks to so when you look at sticking to glass, so when you talk of sticking to glass, let's say you have this is the cup. Okay, so after you pour water from this cup, you're going to find some water molecules attaching themselves there. So these water molecules which are attaching there as a result of adhesion and what? Cohesion forces. Adhesion and cohesion forces. So this is also true. So the only one which is not true, it is water. Water is a poor conductor of electricity. It only becomes a good conductor when ions dissolve in it. So you find that water is a universal solvent. So most of the water we drink, even the one from the rains, are not clean water. So please make sure that you understand that. Water bodies in the lake have constant surface temperature. So this is due to the hydrogen bonds. So the hydrogen bond, they become so strong to cause what? To make water to have the high specific heat capacity. High specific heat capacity. Okay. So it's because of that this thing these guys, because of the hydrogen bond, you find that water has a high specific heat capacity, which is somewhere 4.186 joules per gram per degrees Celsius. Okay, yeah. So this specific high heat capacity is just the amount of temperature which is needed to increase the temperature of a molecule. Yeah, per degree but yeah. So hydrogen bond can be expected to form only between hydrogen and what? Ladies and gentlemen, hydrogen bonds can be formed between anything that has a higher electronegativity. So for example, this guy, it is from proteins. This guy, it is from water and carbohydrate. So in this case, the answer is simply that one. Okay. Then we go on the next guy. Adhesion forces lead to dash, which is a process through which water is absorbed into roots. So the answer is just capillary actions. So if you have done the lab before, you find that you were given a petri dish, and on this petri dish you were told to put some water, and a tube was given to you. So a tube was given to you, and this tube you are told to put it in that water. So when you had to put it in that water, you found that water was able to rise. So this is as a result of capillary action. This is as a result of capillary action, and this is the same one. This is the same concept which helps trees to be able to absorb water down the roots, from the roots. So that's a tree there, it's absorbing some water because of that concept. Okay, so let's quickly continue. So water is a liquid at room temperature because of what? The high boiling point, the high melting point, the high heat of vaporization, and adhesion forces. So it's all about the high heat of vaporization. It is the high heat of vaporization that makes water to take time. That makes water to take time to change from liquids to gas. Yeah, it's that. Okay. The other one is polar molecule can readily dissolve in water because they are able to form hydrogen bonds. They are able to form hydrogen bonds. So it's those hydrogen bonds which are causing some substances to dissolve in water. So polar molecule can form hydrogen bonds with what? With water. Oh, let's look. There is C. Water can interact with charged solutes. No, guys. This is not polar. Charged molecules. Show a bit. It's saying water can interact with charged solutes. What's a solute? Let's get that. Solutes, we are talking about Solutes, anything that dissolve in anything, right? Anything that is dissolving. Not so. Dissolving, that's one. Another word I can pick from this guy is molecule, and the word molecule is used for covalent bonds. Okay, so our answer will simply be equal to 5. Please uh, don't don't get confused. So the answer here is going to be 5, which is A and C. Okay. All right. So biology needs some good analysis when dealing with it. So the most important reason for the unique shape of water is what? Okay, so the covalent bond pattern in water molecule, yes, it does. The pattern, okay. So the pattern is as a result of unequal sharing. It's because of unequal sharing of electron, because of the unequal sharing of electron, and then the bond angle between the two, yes, the bond angle, it is not the way we think, which is linear, but it is bent. Okay, so the bond angle, which is 104.5, it also causes that. So the presence of a lone pair of electrons, so we find that there are 2 lone pair of electrons in water. On oxygen, that water can be that. Okay, so the answer is that one. Which of the following statement is not true about water? So when water boils, all right, that's the answer. Like I said, when water boils, it's not the covalent bond that breaks. Instead, it is the hydrogen bonds that breaks. It is the hydrogen bonds that break. All right. So the next question is, choose the correct statement which distinguish water in liquid. So in liquid water, each molecule is surrounded by 4 other molecules. In liquid water, molecules are more densely packed. In liquid water, the molecules are arranged in a regular pattern. In ice, the hydrogen bond constant make and break. In liquid water, molecules are less densely packed. So the answer here is densely packed. They are densely packed. They are close to each other. They are close to each other. That's why liquid water has what? It has less density. It has less density. So this less density is as a result of the fact that it has what? Small volume. It has small volume. So because of the closeness, no, we can't say it has less density. It has greater density, sorry. So because of the small volume, you find that the density increases, because density increases when the volume is small. So yeah, okay. Capillarity of water in a vessel depends on what? That guy there. So the answer is A and C. So the answer is just up there. Okay. The meniscus of water in a glass tube curves upwards. No, curves upwards. They are saying it's like that, which is not true, right? Is flat. They are saying that it's flat like that, which is not true. Curves downwards. So it curves downward. Yes, this statement is correct, but let's look at other factors. So curves downward, yes, we understand that, due to the cohesion forces between water molecules. Then curves downward due to adhesion forces between water molecules. So the key words there is that one and that one. So curves downward due to cohesion forces. These forces are existing between what? Water molecules. So you find that there is a water molecule down there, there is a water molecule down there, another water molecule there, another water molecule, another. So this water molecule is trying to pull that guy, pull that guy, pull that guy. Yeah, so it's as a result of that you have that downward shape. Okay. In water molecule, the non-bonding electrons in oxygen are how many? How many are non-bonding electrons in oxygen? In a water molecules. I'm sure someone can work out that. Can someone work out that? So you find that there are only 2 of them which are non-bonding electrons. I'm sure we have explained this in the previous explanations. So which of the following statements describe a covalent bond between hydrogen bonds and despite these guys having a slight difference in electronegativity, this guy is not polar. This guy is not polar, for example, in hydrogen or in carbon dioxide. But let's quickly look at some options. The electrons are shared equally. No, they are not equally shared because this one has a high electronegativity. Okay, so each electron in the bond are closely electron in the bond are closer to oxygen, which is correct. So oxygen has the higher electronegativity than carbon. As a result, electrons will surely go to oxygen and not to carbon. But this bond is not polar. For example, in carbon dioxide. Identify the correct description of a hydrogen bond. A bond between oxygen and hydrogen atoms of the same. No. They can be same. A bond between oxygen of water and nitrogen of ammonia. There is ammonia there. A bond between oxygen and hydrogen of the alright. That's the answer. I've already explained. So ammonia is not polar. Ammonia is not polar. But if it was a protein, this would have been correct. Okay. A bond between 2 hydrogen atoms of different molecule. All right. We have an option which is there. So the question which may rise is that, is ammonia polar? Okay, that's very important. So okay, I think I got it wrong there. Ammonia is polar. Please take note that ammonia is a polar. So I made a mistake there. I was too fast. My fastness has costed me. But anyway, take note that ammonia is a polar molecule. So for example, this is nitrogen. Yeah, it's automatically has to be polar. It's nitrogen, so you're going to have hydrogen there. You're also going to have hydrogen there. You're also going to have hydrogen there. Then you discover that nitrogen is more electronegative. So nitrogen is partially negative. Those guys are partially positive, partially positive, partially positive. So in this case, guys, ammonia is polar. Okay, because there is a fact that because nitrogen here it has a high electronegativity, automatically electrons will be pulled towards nitrogen. So that makes option 2 and 3 to be correct. So that one and that one, they are correct. So please take note, ammonia is polar. Choose the statement which is false about water. Okay, water has a high surface tension. Okay, correct. Ice is solid because its water molecule are held rigidly. Okay, so the answer is that. Okay, there are no there are no there are no ionic bonds in water, so that one was supposed to be 4 degrees Celsius. Which word best describe the attraction of a water molecule? Attraction of a water molecule is just hydrophilic. Hydrophilic, yeah, hydrophilic. Hydrophilic means water loving, something that love water. This is water loving. Then hydrophobic, it means hates water, H2O. Okay. Let me quickly go down. When a lipid is mixed with water, the two immediately separate. Why? Oh, why do they separate when you mix water and lipids? So you need to understand that lipids are amphipathic. Lipids are amphipathic. This means that they normally they do what? They normally attract, and also they normally attract and also repel water molecules. Okay, so this is one of the reasons why lipids they don't associate with water. So if this is your grass tube, and this grass tube, there is water inside. Okay, there is water inside. So immediately you put a lipid, what will happen is that the lipid, this is the lipid, it will have the tail. So the tails will these tails will surely be avoiding water. So the heads will be outside, and then the tails will be inside without dissolving. Okay, so like that. So these heads are interacting, but the tails are not interacting. Actually, they form what we call the mesols. I hope it's the right pronunciation and spelling. So lipids are amphipathic. Okay, let me quickly go down. Choose the correct statement about the arrangement of water around ions. So oxygen atom. So you need to understand that what's the relationship. Sodium is positive, oxygen is negative. Okay, so because this guy is partially negative, that is positive, they will interact. Yes, correct. Hydrogen atom, this guy chloride is negative, and then hydrogen is what? Positive, so they'll surely interact. The ion of common salt separates and cluster of water around them. So yeah, which is also correct. Ions of common salt, no, they don't float. So the answer is that A to C is correct. Okay. Water is a liquid at room temperature because of what? What's making water to be that? So there is its high boiling points, it's okay, right? All of the above are correct. So here dipolar is because of an equal sharing of electrons. All right, so let me quickly go down and check out what is down there. So please guys, make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy for those who will be doing medicine and surgery next year, those who will be doing pharmacy, and also those who will be doing biochem, all health related courses. The good part of registering with Excel Academy is that we are going to give you mentors who are going to be your mentors until you graduate. People you'll be looking up to, people who are going to be telling you, no, we don't do this when you reach third year, or you don't do this when you reach fourth year. Yeah, so we have prepared a very strong team which will help you be the best graduate ever. Okay, number 25. The most important reason for the unusual properties of water is because of what? It's just because of the hydrogen bonds. It's all about hydrogen bonds. Why do the atoms of a water molecule attain partial charges, guys? So there is an equal sharing of electron between. That's all. I've already explained that. The cooling effect on plants depends on its. Okay, so the cooling effect, it's as a result of the heat of vaporization. That's all. Because as water as water changes its state from liquid to gas, it leaves a cooling effect, which helps even us human being to feel cool when it's hot. That's the reason why you sweat. You sweat so that that cooling effect can be there. Choose the property which makes water an effective solvent. Okay, so when you look at the options, we are talking about what? Density. Okay, so high surface tension, it just helps some organisms to float. This one is playing in the role of what? The role of, let's say, a spider floating and other stuffs. This one is about changing of temperature. This guy is about changing of temperature. So this guy is playing the role of temperature. Dipolar nature, yeah, dipolar nature. That's why sodium chloride is able to dissolve, glucose is able to dissolve, proteins are able to dissolve, DNA is able to interact. So you find that it's because of the nature. Okay, right, so the answer here is just dipolar nature. Okay, let me quickly go on the next one. Ice is able to float on liquid water because ice is insoluble. No, water freezes at the density of liquid water below the ice surface increase. Water has a high that of the high surface tension. No, water has a high specific heat. No, ice. No, the density of liquid water below the ice surface increases. Okay, so the answer is this one. So if this is your is your beaker, and this beaker is having water there, so you find that when you put ice, so those are ice, so these ice, when you put them there, you find that below there this water has high density, because it's closely packed, and this one has low density. Okay, yeah, so that's the reason why. And density increases as you go down. That's what this sentence means. Density increases as you go down. All right, the next one. Which of the following is true about the type of bond in liquid water? Water contains ionic? No. Contains? No, it's not hydrogen bonds only. Water contains both polar, which is correct. Okay, so the unequal sharing of electron it leads to what? Polar covalent bonds. Okay, and then the hydrogen bond is the interaction between these water molecule. Which of the following substance does not have hydrogen bond? It's just glyceride. So glyceride is a lipid. Okay. The next one. Choose the correct statement about water properties of water. So its specific capacity helps to keep, guys, I've already explained this guy. This one is correct. Its latent heat of vaporization, yes. So please make these two as your answers. Make these two as your answers, and know that specific heat is for temperature. Latent heat, it is for cooling effects and also vaporization and change of state. Okay. So the answer here, ladies and gentlemen, it is 4. Okay, let me quickly go down. When a water body develops solid ice at the surface, life at the bottom of the water, it continues normal. It continues normal. So if this is a lever, okay, if this is a lever and this lever is like that, for example, if I was to visit places like Norway, so when you go to Norway, you find that sometimes there is ice. Even Russia, you find that there is ice on top there. So when there is ice on top there, this ice is acting as an insulator. But you need to understand that a fish down there, it will continue swimming. It will continue swimming and enjoying life. Actually enjoying life better than the human beings who are on Earth. So life underwater continues the same. So this is why also it's very hard for fishermen to fish in cold season, because the fish normally goes down there. So this gives it a very hard job for fishermen. Shout out to all fishermen there who make sure that we have fish. Which statement is false about pure water? It has a pH of that. It is composed of polar molecule. It is composed of ionic bond. No. So the answer is simply that. Okay. Let me go down and look at my next, if at all I have a next question. So the next question is, which of the following statement is correct? So the specific heat capacity of water is low. No, it's very high. So it's very high. Water freezes at 5 degrees. No, it is at 4 degrees. Water expands as they know it decreases. A lot of energy is required. Yes, it is true. Okay, so hydrogen bonds are very strong when they are together. Okay, when water is consumed in a biochemical reaction, the process is called what? So what do we call a process when water is consumed in a biochemical reaction? What do we call that process? So that process is known as what? Dehydration. Yeah, the loss of water. So we can talk of which process? Dehydration. Can we talk of which process there? Which process is the same as a dehydration process? Okay, so when water is consumed, okay, so consumed meaning used. Okay, so this reaction is just hydrolysis. Okay, meaning water is used. So when water is used, it's just hydrolysis. Yeah. So for example, let's say you get glucose and glucose to make maltose, okay, to make maltose. So from this process to that process, it is condensation. Okay, and then from that process to there, it is hydrolysis. Okay, all right, so the answer is just hydrolysis there. Why does water Why does ice float on water? Water molecules further apart. The crystalline lattice of ice causes it to be denser. That one, no. Ice always has bubbles, no. The ionic bonds between the molecule in ice, ionic bonds, no. Hydrogen bond keep water molecule further apart in ice than in liquid water, which is correct. Okay, the next one is choose the statement which is false about water. Okay, so water has a high surface tension due to, which is correct. Ice is solid because its water molecule are held rigidly, ionic bond again. So the answer is that. Here it was supposed to be 4 degrees Celsius. Alright guys, thank you for joining me once again. This is Dr. Possibility from Excel Academy. To get in touch with me, please you can WhatsApp me on 0965 887474 or slash 097 sorry 0974840616. You can get in touch with me on those numbers, and remember Excel Academy will be offering courses like anatomy, biochemistry, physiology, organic chemistry, microbiology, immunology, pharmacology, for those who are going to go to pharmacy to do pharmacy. So these are some of the courses we'll be offering at second year. So please make sure that you subscribe to our channel. Thank you and have a blessed day.